Hello everyone, welcome back to Mr. Exams Professor. In the previous video, we learned about what is an algorithm, what is algorithm analysis, characteristics of an algorithm, why algorithm analysis is important. Today we are going to understand the heart of algorithm analysis, that is nothing but space complexity and time complexity. This is one of the most important topics in the entire ADA syllabus. Entire ADA, this is one of the main topic. So without understanding this topic, you cannot understand AVL trees, sorting, graphs, and dynamic programming. Also, any algorithm. So that is why it is the heart of the ADA. So by watching this video completely, you will never be confused about time and space complexities. So let's begin. So today, Unit-1. Space complexity analysis. Space complexity analysis and time complexity analysis. These two topics. Before explaining anything by me, ask yourself one question. Suppose two software engineers write two different programs. Both programs give the correct answer. So you have to choose which one is better. So can we say both are equal? No, because the correct answer alone is not enough. The program should be fast, efficient, use less memory. So that is why we analyze algorithms. So real life example, I'm going to give one. Suppose you are traveling from Kochi to Thiruvananthapuram or Hyderabad or Bangalore, any of the city. Suppose as a real life example, I can say that suppose assume route 1. So distance total is 560 kilometers. Time taken is equals to 8 hours or anything time. Okay. So for example, you can say diesel or petrol, we can call fuel. We can call it as fuel. Fuel is equals to 35 liters. Fuel. So the same way, route 2, distance is equals to same 560 kilometers, but here time is equals to 11 hours. Fuel is equals to 52 liters. So as a real life example, we can say that route 1 is better. Why? The time is less, the fuel consumption is less, but yet the same distance. So we can say better efficiency. Now in the sense, while comparing with the algorithms, the fuel here is memory. So the time is execution time. So this is the most important. So you have to keep this in mind. So this is the exactly same concept. So keep this in mind. This is one of the important. So this is exactly what algorithm analysis does. It checks mainly two things. How much time and how much memory. This is it. So we are going to dive into the main topic. Time complexity. Time complexity. So time complexity does not mean the actual time measured in seconds. So we B.Tech students usually think like if our laptop used to execute in 2 seconds, so time complexity is equal to 2 seconds. That is very wrong. Time complexity only measures how the execution time grows when input size increases. So I can say that time complexity is growth of execution time with respect to input size. So here n means number of inputs. So n is equals to input size. So let us take an example. What we can say, yeah, let us take array. Array contains 100 numbers. 100 numbers or whatever it is, it's your wish. N is equals to 100. You can take any number, like array contains 1000 numbers, n is equals to 1000, array contains 10, n is equals to 10, or whatever it is. So we B.Tech students used to see the professional examples. So this is very important because you have to show professionalism. So example, what we can say, yeah, suppose Google has 100 web pages, search becomes easy. Now imagine Google has 100 billion pages or more than that. Will searching take the same effort? No. As data increases, searching becomes harder. Therefore, Google designs efficient algorithms. So that is called time complexity. So why time complexity? Why? Why time complexity? So the main need for time complexity is to compare algorithms. Second one for better performance. Third, we can say user experience, for better user experience. And quick execution means faster execution. So that's it. Suppose we can say, as an example, you are very much acquainted with Instagram. So if Instagram takes 12 seconds to open, will anyone use to open the application? No. Whenever you used to click the Insta application, it is used to appear as soon as possible. So users uninstall the app if it doesn't work. So companies send crores of rupees making algorithms faster. That is why the big companies like Google, Amazon, yeah, Microsoft, Meta, etc. all hire algorithm engineers. They used to hire algorithm engineers. So this is the concept of time complexity. Do see it. So now dive into the topic of space complexity. So space complexity. Space complexity means how much memory an algorithm needs while execution. The amount of memory an algorithm, yeah, needs while execution is called space complexity. That means space complexity means memory required during the execution. During execution. Now memory uses RAM, not hard disk. Many students write hard disk memory. This is wrong. Always remember, space complexity means RAM memory. Note this point very strictly. Space complexity mean RAM memory. So you have take, for example, you take 8 GB RAM. One software requires 2 GB RAM. Another software requires 12 GB RAM. Which software runs smoothly? Obviously 2 GB RAM software, because less memory and better performance. For example, if we can say a real life example, you are traveling. While you are traveling, you carry one small bag. Easy. Now imagine you carry 8 heavy bags. Walking becomes difficult. So like more luggage means more effort. Similarly, more memory means more resources. This is important. So here more luggage means more effort. So similarly, more memory means more resources. So time versus a space. Now we are going to explain. I'm going to explain about time versus space. Time complexity versus space complexity. So these are the major topics. So here, time complexity is the execution time, whereas space complexity means memory usage. So for example, I'm going to ask you, algorithm A is very fast and uses more memory. Algorithm B is slightly slow, which uses very less memory. Which one is better? Which one is better? So I'm going to answer it. It depends upon the requirements. Sometimes companies prefer fast algorithms, sometimes memory saving algorithms. There is no universal answer. It depends. So here's the important one. This is very important for students, exam point of view. You have to write in the box, like you can write like in the box or like a flowchart. Good algorithm means less time complexity. Plus less space complexity. This is the important point. Do note this. So the sentence alone is frequently asked in some viva and semester examinations. This is very important because this is the core. A good or the best algorithms has less time complexity and less space complexity. So here you will write some of the common mistakes, like what students used to fail in the trap. I'm going to say that also. So what are the common mistakes students usually do? Common mistakes are nothing but time complexity is not equals to seconds. space complexity is not equals to hard disk. N is equals to input size. This is the blunder things which students used to remember. So do follow this and have a glance at it. These are the common mistakes which students usually do. Okay, in this video I have explained about time complexity, space complexity, input size, need, examples and comparison. Yeah, we have learned about the time complexity. Space complexity, input size, need of this time and space complexities, a couple of examples, comparison of time and space complexities. So today we have understood about this time complexity, space complexity, input size, need, examples and comparison. And I have also told about some professional examples and real life examples, and also the comparison. So in the next video we are going to learn one of the most important concepts in NDA, asymptotic notations. So thank you guys, hope you understand these concepts. So please do read this before going to semester examinations, because this notes is very useful for you in the examination point of view. So please do not, if you haven't understand any topic, just go through these topics which I have explained you, and you can get a quick glance before the semester examinations. So without hurry studying all the sites or something, all the notes, etc., just have a look at these notes, because you will understand very clearly. Because I have given some small and understandable examples and understandable concepts. Hope you like it. Thank you guys. See you in the next video. Bye. Please do like, share and subscribe. Bye guys.